Hi guys, hope you're doing well wherever you are. Welcome to lesson 9. We are starting on graphing piecewise functions. So let's take a look first at what Delta Math sections you have in store for you this round. 1 is writing equations of lines, which you already did last week. 2 is inequality notation and interval notation. And 3 is writing piecewise functions from a graph. So I'm not going to go over the first section because you've already done it. Jumping into inequality notation and interval notation. So this is something we've already done, but I want to touch on it just to make sure that we've got it all down. When you have a function graphed, you will see two different possibilities. You will see the ending either be an open circle or a filled in circle. If it's an open circle, that means that the function starts right after where that point is. So that is when you would draw, right, more than or less than, but not equal to. If it's a filled in circle, then it is greater than or less than and equal to. That is inequality or set notation. If you were to use the same concept, you're showing the same graph, but in interval notation, instead of the alligator chompers, you would have the parentheses. That would show you the same type of information. If it includes, right, it's less than or equal to or greater than and equal to, or it's a full circle, in interval notation, you would use a bracket. And let me write that right here. This is an example of interval notation. So I hope this helps you for your second section of your Delta Math. Third and last thing is writing a piecewise function. So we're not exactly graphing it yet because graphing it takes a little bit more work. What you are going to do today is you are going to write a function based on the graph. So 3 easy steps. So 1, you're going to identify the number of pieces there are. 2, you are going to identify the domain, so for what values it's going to be valid. And 3, you are going to identify the expression. So for this level of writing a piecewise function, let me take my little box out. The number of pieces, because it's level 1, I'm pretty sure all of them, there's only going to be 2 pieces, meaning there's 2 rows. Then you are going to identify the domain, which goes right here. This is a screenshot from Delta Math. So this is exactly what it's going to look like. And then you're going to identify the expression that it needs to satisfy. So for example, you will get a graph like this, right? You are going to see visually on the graph, there are 2 pieces to it. Awesome, we're good. I don't have to add any pieces. Then you're going to look at the domain. So for what x values am I writing a function for? So that's what goes into the right-hand boxes under domain. Then you are going to write an expression, right? Because it's not enough just to say, oh, for all these x values, for all these x values, what is happening? What does the line look like? Is it a horizontal line? Is it a vertical line? Is it an increasing diagonal line? Is it a decreasing diagonal line? So that's why you've been practicing writing equations of lines so that you can very quickly tell me what the rule here is. Tell me what the slope is, what the y-intercept is, and write those expressions that match the correct domain. Piecewise functions will always go left to right. So they'll always go from the smaller domain to the larger domain. And you're about to jump into some examples right after this quick CFU. So once again, text me, email me, write in your private comments to this assignment. Which of the following is not a step to writing a piecewise function? So pause this video and message to me one of the answers for a reward, probably a cut-in homework.
Express the function graphed on the axis below as a piecewise function. So I see 2 pieces, so I'm going to have 2 rules. Now, the domain of this piece, since it's going all the way left to an x value of negative infinity, and the biggest x value on the piece is negative 3, we could say that the domain of that is any value of x which is less than or equal to negative 3, because less than negative 3 represents to the left of negative 3. So the first domain will be x is less than or equal to negative 3. You can press the less than then equal sign on your keyboard if you want. But what is the rule? Well, the equation of this piece, since it is horizontal, is constant. The y value everywhere on this line is 5. So the rule for that is the constant 5. Now the other piece, its domain begins at 2 and then goes 3, 4, 5, 6 as far as x values. So the first x value is 2, but we're going to the right, so we would say that the domain is x greater than 2. Now we would not put an r equal to sign for the 2 because there is an open circle. So really the first x value is really like 2.00001, but we will just say x is greater than 2 to represent that interval. So what is the equation of this line? You have to imagine being able to extend this line into the y-axis, because the equation of a line that we're going to use is mx plus b. Well, what is the slope? We can actually tell that the slope is from this point to this point, right 1, up 1, 2, 3, 4. So it's right 1, up 4. Therefore, the slope is rise over run, which is 4 over 1, which is, of course, just 4. But can we tell what the y-intercept is? Well, we have to extending this line. So if going backwards, we would go down 4, left 1. We'll go down 4, left 1 again. And then from 1, negative 2, we'll go down 4, negative 1 again. So if we were to extend this line, it would extend all the way to a y value of negative 6. Therefore, the equation of the full line would be 4x minus 6. So that means the rule for this whole piece is 4x minus 6. But we would write the domain x greater than 2, which cut it off. So we can't actually see the y-intercept of that line. So our next example, it has, again, 2 pieces. Now, but each piece does not go off to negative infinity or positive infinity. The domain of this first piece is from negative 4 to an x value of 0. Make sure you don't read the y value of this point. The domain is negative 4 less than or equal to x is less than 0. Now, the reason we use less than or equal to x here is because x is allowed to equal negative 4. I see a dark circle, a closed circle, means that that point is included in the domain. But this is an open circle, so when x is 0, this rule shall not apply. In fact, this rule up here also does not apply when x is 0. Our function is undefined when x is 0. Now, what's the domain of the second piece? Well, the first x value on the line is 0, and the last one is 3. But 0 and 3, x values both have open circles. So we would actually write 0 less than x less than 3, and neither of them would have the or equal to sign. So now we know rules for each. Well, the flat line is the easiest one because the y value on this segment is always 6. So the rule is simply 6. F of 1 is 6. F of 2 is 6. F of anything in this interval would be 6, represented by this constant value. Now the other one is not horizontal, which means it has a slope. So what is the slope of that line? Well, we could choose any 2 points. If I choose that point and that coordinate point, I see that the pattern is down 3, right 1, down 3, right 1, down 3, right 1. Well, the slope is rise over run, and the down 3 would be minus 3, and the right 1 would be over 1. So the slope is negative 3, and it is decreasing, so that makes sense. So the equation of the full line would be negative 3x, and the y-intercept, fortunately, we can actually see the y-intercept of the line is here between negative 4 and negative 6, which is negative 5. So this is the equation of the full line, but we're restricting it to a domain of negative 4 to 0, and make sure that you don't write y equals. We just write the linear expression that would represent that line.